Our next video is on bar graphs. So a bar graph is a way of displaying actually any kind of quantitative data. We'll talk a little bit about the different kinds of data that you can display in a bar graph in this video. But first I want to show you an example of how we create one, creating a frequency table and then using it to create a bar graph. And then we'll talk some about what they're used for. So you can see this is an example. I've got the number of pets owned by a family. There are 20 different data points here, and so I've collected all these values. This is quantitative discrete data, right? So there are only 6 different values here, not a lot. We can look at each of them individually. We don't have to group them together. So quantitative discrete data, and bar graphs are really good for working with quantitative discrete data, kind of no problem. Okay? So the way we create a bar graph, so we start out with the data, right? We've got just these values. Before we can create a bar graph, we need to create what's called a frequency table. Okay? And so a frequency table basically is just a way of taking and writing down all the different values that we have and then filling in how many of each of those we have. So this is called the frequency. So for example, if you look at the data, there are 4 zeros. There are 5 ones. There are 4 twos, 4 threes, 2 fours, and 1 7. Okay? So that's called the frequency. Again, it's just a count of how many values match that. Pretty easy to get. Just be careful when you're doing it, especially with more complicated data sets. Make sure you count everything carefully. There's an example on the homework where there are 51 different data values, and if you don't count them carefully, you'll get these numbers wrong. So that's frequency. The relative frequency is just the percentage that each of these makes up. Okay? So for example, there are 20 different data values here, and 4 of them are zeros. So that means 4 out of 20, or if you make that into a percentage, that's 20%. Okay? And so relative frequency we usually write as a percentage, 20%, 25%, 20%, 20%, 2 out of 20 is 10%, and 1 out of 20 is 5%. Okay? So you can write this as a percentage, you can write it as a decimal, right? So also writing 0.20, right? So 20% is the same thing as 0.20, 0.25, 0.20, 0.1, and 0.05, right? So that's actually probably the most common way to write it, is just to write the decimal representations of the percentages. Okay? So you'll notice that your frequencies should all add up if you total them. All of your frequencies add up to the number of data points that you have. So there are 20 data points total. If you add up your relative frequencies, 45, 65, 85, 95, right, they add up to 100%. Okay, so that's always a good check to make sure that you've gotten these numbers right, is that your relative frequency should add up to 100%. Okay, so that's the frequency table. Once we have it, we can create the bar graph. Okay, so over here on the right, I have my bar graph kind of already set up. You'll notice I've got spots for all the numbers from 0 to 7. If you remember when we talked about misleading graphs, I said it was important not to skip numbers. So we're going to put everything in, even 5 and 6, even though there are 0 in those spots. And so to create the bar graph, you're just going to fill in a bar with height equal to the number of the frequency, right? So for 0, the frequency is 4, so we go up to 4. For 1, the frequency is 5. For 2, it's 4. For 3, it's 4. For 4, it's 2. For 5, it's 0. For 6, it's 0. And for 7, it's 1. Okay? And that's a bar graph for the number of pets owned by a family. Okay, so you can also do this if you'd rather graph, or sometimes the question will ask to graph with the frequency as the y-axis label or with the relative frequency. So if you used relative frequencies here instead, you would just change all of these labels. It doesn't actually change any of the heights of the bars. So if I changed all of these to relative frequencies, I'd get the exact same graph, but I would have 0.05, 0.10, 0.15, 0.20, 0.25, right? And you can see 0 has 0.20, 1 has 0.25. Everything looks exactly the same if you use relative frequencies instead of frequencies. Just be careful and use whichever one the problem asks you to do. Okay? So the bar graph, important things to do with bar graphs. Remember, a bar graph should always start at 0 on the y-axis. So your height of your bars should always come up from 0. Don't start at another value. If you plug something into Microsoft Excel, it will start at another value and you'll get it wrong. So make sure you're careful with that. You always want to start at 0 so we can actually compare the height of the bars and give us an idea of what the data looks like. Okay? In the next video, we're going to look at what's called a histogram, which is a type of bar graph for dealing with quantitative continuous data. But I want to talk a little bit before I move on to that about the different ways we can use bar graphs. Okay? So if you have a bar graph, your y-axis will always be frequency or relative frequency. Okay? So whenever we create a bar graph, the y-axis is always frequency or relative frequency, however many values there are, whatever percentage of the values are that. The x-axis can actually be lots of different things. So you can have quantitative discrete data, like we just saw, or you can have qualitative data also. So if you've got data that's qualitative, so maybe a different bar graph might be, for example, the grades that people got on an exam, right? And so it might have A, B, C, D, F. So your bars can correspond to values of qualitative data on the x-axis as well. Okay? And we can even do quantitative continuous data. Okay? So if our data categories are quantitative continuous, we need to group them into ranges of values. Okay? And so this gets done a lot anytime we have quantitative continuous data to deal with. Such a bar graph is called a histogram. Okay? So if you've seen a histogram before, you may think, oh, it's just a bar graph. There's not really any difference. But what a histogram is a bar graph where the x-axis values are grouped into categories. Okay? So let me give you some data. I'm just going to give you the frequency table and let you kind of explore. Well, actually, no, let me give you some data and we'll talk about how to put it into a histogram. So I'm just going to do 20 data points, so I don't want to do a lot, but a lot of times with a histogram, you're going to have a lot of data points. So let's do a histogram. Let's say a biologist weighs 20 marmosets. Okay, so if you don't know what a marmoset is, that's fine, it doesn't actually matter, right? So a biologist weighs 20 marmosets. Their weights in grams are 207, 223, 234, 238, 239, 242. Let me actually write these in rows of 5 so that I don't forget them. 242, 243, 245, 248, 248, 249, 250, 251, 254, 256, 258, 264, 265, 273, 278. Okay? So what I've got here is quantitative continuous data. So you'll notice here lots of different values, okay? And other than a couple, maybe just the one, there are 2 values that are 248, but other than that, each of these is unique, right? And so if you just did a bar graph, the frequency of each value would be 1, and you would have a bunch of bars that are exactly 1 high, and this graph wouldn't be very useful, okay? So what we're going to do instead is we're going to build a frequency table where rather than looking at the frequency of just one particular value, we're going to look at the frequency of categories, okay? And so we're going to split this up into, well, let's say 8 categories. So 200 to 210, 210 to 220, 220 to 230, 230 to 240, 240 to 250, 250 to 260, and 260, oh, I need one more, out of space. Let me rewrite those. So 200 to 210, 210 to 220, 220 to 230, 230 to 240, 240 to 250, 250 to 260, 260 to 270, and 270 to 280. Okay, and I'm going to put in frequency and relative frequency. Okay, so now rather than counting the frequency of individual values, since most of those frequencies are just 1, we're counting the frequencies of categories. Okay, so how many values fit in 200 to 210? Well, there's 1, just 207. That's the only one in that category. How many in 210 to 220? 0. That's pretty easy. 220 to 230, there's 1. 223. 230 to 240, there are 1, 2, 3, 1, 2, 3. 240 to 250, we have 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. And this is where it gets a little bit tricky, because there's actually a question that you can ask yourself. Where does 250 go? Okay? So the way that I've written this, I've been a little bit sloppy. So I've written 240 to 250, and then 250 to 260. Do we count 250 as being in this one or in this one? We don't want to count it in both, is the most important thing. Okay? So you never want it to end up in both of the different categories, because then your counts are going to be off, your relative frequencies are going to be off. Okay? So my recommendation, and just a rule of thumb, is that you put it in the first one that it fits in, and then leave it out of the second one that it fits in. That's probably a good rule of thumb. If you want to do it the opposite way, you can, but make sure you just keep it in one, okay? So 240 to 250, we're going to place it in there. So these 1, 2, 3, 4, 5, 6, 7 values go in that range. 251, 254, 256, 258. 4 values in 250 to 260. 2 in 260 to 270, and 2 in 270 to 280. Okay? So just make sure you just count it in one of the values. That's what's important. So we've got 2, 5, 12, 16, 18, 20 values, which is good. That's how many we have listed. And so these numbers should add up to the same. We can do the relative frequencies. 1 divided by 20 is 0.05, 0.0, 0.05, 0.15, 0.35, 0.20, 0.10, 0.10 for our relative frequencies, which add up to 1, to 100%. And then we can create a bar graph. And so your bar graph now, rather than having a single number listed at the bottom, it's going to have these ranges. So I'm not going to draw the whole thing because it's a lot of work, but 200 to 210, 210 to 220, right? And you can list them this way. You can also do something like 200, 210, 220, 230, and so on, and then put in your frequencies. 1, 0, 1, 3, and so on, and complete the rest of the bar graph from that. Okay? So that's all that a histogram is. So a histogram, remember, is a bar graph where the horizontal axis has ranges of quantitative continuous data. Okay? And so a histogram lets you graph quantitative continuous data on a bar graph, just like we graphed quantitative discrete and qualitative data. Okay? And so this makes the bar graph one of the more kind of versatile graphs that we have, which is part of why you see it used so often.